This video is on Pythagorean triples. And the first thing we're going to do is fill in this chart with the legs and the hypotenuses to get our Pythagorean triples that we're starting with. So we're going to use Pythagorean theorem to kind of figure out the missing pieces. So on this one, we've got 3 squared plus 4 squared is going to equal our hypotenuse squared. So 3 squared is 9, plus 4 squared is 16, which gives us 25. The square root of 25 is 5. So we've got 3, 4, 5. That's our first Pythagorean triple. Next up, we are going to find our missing leg. So here we've got 13 squared is our c squared. We don't know what our first leg is, so I'll call that a squared, and we've got 12 squared here. So 13 squared is 169. And then we're going to subtract from that 12 squared, which is 144, and we get 25 here. A squared equals 25, which means A equals 5. So 5, 12, 13. On to the next one, we've got 7 squared plus b squared equals 25 squared. So we're going to do 25 squared, which is 625, minus 7 squared, which is 49, which gives us 576. And if we take the square root of 576, we get 24. Next up, we've got 8 squared plus 15 squared equals c squared, or our hypotenuse. 8 squared is 64, plus 15 squared is 225, which gives me 289. If we do the square root of 289, you get 17. So 8, 15, 17. Next up, we've got 9 squared plus b squared equals 41 squared. So let's do 41 squared. That's 1,681 minus 81 gives us 1,600. The square root of 1,600 is going to be 40. Then we have 11 squared plus b squared equals 61 squared. So 61 squared is 3,721 minus 121, which is 11 squared, gives us 3,600. If you do the square root of 3,600, you're going to get 60. And then last but not least, we've got a squared plus 112 squared equals 113 squared. So 113 squared is 12,769. And then 112 squared is 12,544. So let's subtract those and take the square root. 12,769 minus 12,544 is square root of 225, which is 15. And those are our lists of Pythagorean triples to get us started. Just as a reminder, any multiple of a Pythagorean triple is also a Pythagorean triple, which basically means if we were looking at our first Pythagorean triple and we multiplied it by 2, 3, 4, 5, and we multiplied each piece by 2, and we would get 6. 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. This is also a Pythagorean triple, 6, 8, 10. So that would also work. Keeping going here, let's look at step by step how we can solve these Pythagorean triple and Pythagorean theorem problems. The first thing we're going to do is identify our GCF, if we have a GCF. If we have a GCF, we're going to divide all lengths by that GCF. Then we're going to choose our Pythagorean triple that we're using. And then we're going to set up a proportion and solve for the missing side. So let's do an example here of this. If the length of all three sides of a right triangle are integers, determine the third side and whether the third side is a leg or the hypotenuse given. So right now I've got side lengths with 40 and 75. So we're looking for the greatest common factor that these two have in common. So right away I see that they both end in 0 and 5, so they're both divisible by 5. So let's see if this is the greatest common factor here. So if we divide both by 5, we get 8. 75 divided by 5 is 15. So it looks like the GCF here is 5. So that was our first step. Our second step was dividing, which we did right here, and we got 8 and 5. So our third step then is to pick our Pythagorean triple. So our Pythagorean triple here that works, 8 and 15, 17 is what's missing. Our hypotenuse is what's missing. So the Pythagorean triple here is 8, 15, 17. Our hypotenuse is what's missing. So we know these two sides, so we're going to use a proportion to find our missing side. So 8 to the original side of 40 equals what we're missing here. So this is what we don't know. And the original amount, or the original triple amount, would be 17. You could also set 17 over x equal to 15 over 75, and you would get the same answer when you solve your proportion. So looking at this, I'm just going to use this one here. We're going to cross multiply. We get 8x equals 17 times 40, which gives us 680. Divide that by 8, and you get x equals 85. X equals 85. So our hypotenuse here is 85. And that is our answer. Let's go ahead and try another one here. We've got 14 and 50. So let's find our GCF of the two. So things that multiply into 14 are 7 and 2. 50, we've got, let's stick with 2 because 7 doesn't go in, 2 and 25. So our GCF here is 2. So let's go ahead and divide by our GCF. And we get 7 and 25. To identify our Pythagorean triple, we're going to go up to our chart. So 7 and 25, I see is right here, this third row, 7, 24, 25. So we're missing a leg, which is 24. I'm just going to write leg equals here for our ending result. And now we're going to set up a proportion. So we're going to use, I'm going to use the first length. So 7 over the original length, which is 14, equals 24 over what we're trying to find, which is x. Cross multiply here, we get 7x equals 14 times 24, which is 336. Divide both sides by 7. And you get x equals 48. So our leg here is 48. And that is it for determining Pythagorean triples.